So what we're going to do here, we'll do both ways. We're going to have you actually scooch into this. And so if we do this here, the color is not going to be right. Because what I want you to do is be illuminated by these guys. So you're going to scooch down like this. Yeah. Or yeah, John can do this. There we go. Okay, so this, we need it to be behind where the light is. So I'm going to go ahead and I'm going to set my custom white balance here. I'm going to say, hey, custom white balance. I've got that. I'm going to take a picture of this card here. Bam, I got it. Then I'm going to go into my menu and say custom white balance. Bam, use this one for the right setting. We're going to put this down. So the exact same thing I did with the Expo disc. And then we're going to take a picture. Don't you love it? There we go. And we'll see that my exposure was a little off, but our color is, I need to bump up my ISO. My exposure is off because the camera exposed for this and not her, and so that was off. But her color is right. And so that was a crash course in that. But basically, you just take a picture of the card and then set it in the camera and say, this is white. That's how that works. Okay, we have much more to go. Yes, we're done with you for now. I'm guilty of always forgetting to tell Lex that she's finished with her thing, and then she'll just be standing there for a while. And she's like, doo-doo. Okay, so let's go back to the keynote really fast, and I want to show you that color wheel again. So these guys are going to flip over to keynote here in a second. There he is. All right, color wheel. So in Lightroom, there are two sliders for color temperature. One is the color temperature slider, and the other one is for tint. And I want to show you how these correspond to color. So if we look, we normally talked about blue to amber. And I put this arrow here on purpose because when we mix yellow and red here and we get this nice mixture, we actually don't get yellow, we get an orangey color. And so I don't have orange on here, but if you look over here, when you see that when you're mixing our red and our yellows, we get an orange. So the orange and blue. So when we're doing our white balance, you're going back and forth between these two spectrums of this mix of colors. But what about tint? Where does that come in? Well, tint is actually this way. So green to magenta. So we have those two things. And so we're actually going in opposite directions of this mix of color. And so if we zip back into Lightroom really fast, you can see that's how it lines up. You can see clearly that it lines up. There we go. Lines up like that. So we have tint up here. This is that blue to amber that we were talking about, and this tint is the exact opposite on that stuff. And so, man, I wish we had more time to go through color theory because it's fascinating, the color theory stuff. All right, so back really quickly to our keynote. We've got more stuff to show you. Just to mess you up, light, as it travels through the atmosphere, light travels in wavelengths of red, green, and blue. Those are our primary colors. When that is printed using pigments and ink, guess what? The primary colors are the exact opposite. Now they're cyan, magenta, and yellow. So if you look at this, so this is cyan, magenta, and yellow. The opposite of yellow is blue. The opposite is red. The opposite is green. And so colors in print are exactly the opposite of colors in light. And again, just so if you're wondering why I had the primary colors mixed up, they're not. There's two different sets of primary colors. And so we're talking about red, green, and blue. I can see you guys are going, what are you talking about? Oh my gosh. Yeah, make a note. Color theory class, we need that. We need that. Okay, so let's talk about stops really fast because we haven't, you hear about stops all the time as we're talking about light. Yeah, that needs to be a stop brighter, stop less. What the heck is it? What is a stop? All a stop is half as much or twice as much. That is it. And so if I had a person that was 3 feet tall and we had a person that was 1 stop taller, that person would be 6 feet tall, right? But it's exponential, so it doubles every single time. So 1 stop is twice as much light. 2 stops is 4 times as much light. 3 stops, it just gets bigger and bigger. So 9 stops of light, how much more light is that than 1 stop? Well, you can do the math. So it's 2, 4, 6, 8, 16, 32, 64, 128, 256, 512. 512 times as much light is 9 stops. And then it goes on and on. I used to be able to count in binary. It was weird back when I programmed my VIC-20. So yeah, 9 stops of light isn't like, the difference between 9 stops and 5 stops is spectacularly more light. And so it's important to understand that when you're talking about it, it's an exponential ramp up And that affects something called dynamic range. Dynamic range is something that we hear about a lot, and here's the definition. Please don't read that, it's horrible. This came from Wikipedia, I think. Yeah, so dynamic range, let me explain it in normal terms, because this doesn't make sense at all. This is a sciencey thing. If you look at a bunch of light here, and these are stops, right? This is absolute black, this is half as much, all the way to absolute white. Okay, this is light as we see it. Our eyeballs can see about 24 stops of light, from the darkest to the brightest. We can see about 24 stops depending on your vision. Mine not so good, and yours is probably great. But you can see that we can look at something like, the other night I was walking down the street and I could see clearly the Space Needle in silhouette with the sun going down behind it. It looked really cool, and the shadows and stuff. And so we're trying to take pictures of that. And all we got with the camera was a white mass of nothingness and the streets, right? Because our cameras can't see all the different ranges of light that we can. If you've ever taken a picture at the beach at night with the sunset, you get beautiful sunset and silhouetted people, or you get people and totally blown out sky, right? The reason for that is our cameras, they can't see all of that light. So what they can see, if you're shooting in film or you have a medium format camera, you can see about 12 stops of light. So you can see quite a bit, but nowhere near as much as we can see with our human eyes. If you're shooting with a normal DSLR camera like we have, you can only see about 5 stops of light. So you can only see this much. So in the situation where we're looking at the beach, we can see the bright sunlight and we can see all of our friends, and our camera can't see either one of those. It can only see the middle ground. And so with our cameras, we have to use light in ways that we compensate for this limitation of dynamic range. And so what we will do is, if we have a situation like the beach, what we would do is we would say, all right, I'm going to shoot the sunset, and I know everybody in front of that sunset is going to be pitch black. And so I want to compress the dynamic range. I want to compress all this light. So I'm going to expose for this right here. This is the sunset, this really bright stuff. But I know my friends down here are not going to show up. So I need to bring my friends up here into this range. So how do I do that? The way you do that is you use a flash, and you add light to them. And so their luminance, their brightness, is closer to the sun, and it will fit within the dynamic range of your camera. Or you'll do the opposite. There are things called neutral density filters. Sometimes you'll have a beautiful field, but the sun is just way too bright. And so you can get this thing that's called a graduated neutral density filter. It's a thing that actually slides onto the front of the camera, and it's sunglasses for your camera. And so you can just darken the sky and leave everything else the same. So you're making the sky dark, but you're leaving the ground the same. And so you're shrinking that dynamic range to fit everything in. That makes sense? Okay, we're going to be, yes, ma'am.
White balance where it was if you put a neutral?
You do, because a neutral density, that's a great question. You get bonus points. You're the first person to get bonus points. How many? We're going to give you 100 bonus points. Yeah, it's called a neutral density filter because it only impacts the luminosity, the brightness of the image. It doesn't affect the color at all. And so it's neutral. And yeah, so your color is going to be fine. It's just the brightness level goes down. Perfect. Okay. All right, so if you'll hold this for me, and we're going to actually have you come out here where there's a little bit more light. So what we have here is and Lex is wearing this shirt and outfit on purpose, because we want to show you that we have different dynamic ranges. So we have black, gray, white, and we have different grays here. We've got different colors on our eyes and stuff. Can our camera capture all of this properly? And so what I'm going to do is I'm going to take my ISO, since we're using just normal light. I'm going to shoot at an ISO of 1250, and I'm going to leave my white balance to auto for now, and we're going to shoot at about 2.8. So hold that up about right there. Yeah, right on your shoulder. There we go. I'm going to see what we get. Okay, perfect. That's good. Thank you.
Want this back?
Sure. Okay. Here you go, John. I'm going to see how many I'm going to get you this. Okay, let's take a look at what we have here. And we haven't talked about why our camera is so bad at figuring out what the exposure values are. But when we look at this image, take a look at this. here we have this white, and we have black, and we have that. Let me see if I can make this not zoom quite so much. Oh, sorry, the wrong way. I went the wrong way. Something like that. Okay, there we go. So is this black actually black? On that screen, it's not black, right? It's gray. This is gray. Is that actually white? We have this tool called the histogram that can help us out a little bit. And it's up here on the right-hand side of the screen. And what this histogram does is this over here is how much we have of blacks. And we're going to do histogram on the last day, actually. This is where middle gray should be, and this is where white should be. So this white here isn't even close to white. It should be way over here. Not even close. So what we can do to try to help fix that, we can change our exposure a little bit. So we get the whites more white. But as soon as we make the whites white, look what happens. Now the blacks are being pulled with it. And so the problem in photography is a lot of times you can't get whites absolutely white and blacks absolutely black in the camera. In fact, they made a big video that was very controversial that said you can't get it right in camera ever. That went over great. Google it. Mark Wallace, getting it right in camera. And I did a bunch of science and built all this kind of crazy stuff to prove you just can't. It's just not possible. And still, even with the science, people get mad at me. So what we have to do is, if you shoot in RAW, you can do some things. For example, you can change your exposure there just a little bit to make sure you get the middle gray right. And then you can come in here and you can start changing these things, shadows, blacks, whites. And we can say, make our blacks black, make our whites white. And then you actually get black, white, and middle gray. And that works great. And so you actually get a calibrated tonal image. So the blacks are blacks, the whites are whites, which you should be able to do. So on the last day, we're going to talk a lot more about this, white points, black points, and all that kind of stuff. All right, so let's talk about how dynamic range is determined. Like, how do you get more dynamic range in your camera? Yes, keynote again will come up in a second. So I'll let Lex look. Okay, there we go. Photons. Photons. So light actually travels in these little packets. They're physical things. Light is actually is matter. It's a substance. It's just like anything else. Isn't that weird? Light is like air or water or anything else. It's an actual thing. So it travels in these little things called photons, or little packets of light. And depending on the luminosity, the brightness, or the darkness of light, these photons are either, there are more of them or less of them. And scientists out there are just cringing. So think of them as little, like a bunch of, I used to have M&Ms and I'd have bowls to do this, but think of them as like little M&Ms. They're just flying through the air. And our camera's sensor has these physical buckets. They're called photosites. They're actual little buckets that physically catch the photons. So this is an actual physical thing that's happening. It's fascinating to me. And it's happening at a very, very small level. And so what those buckets do is they physically fill up with light. This actually happens. These photons fill up these little buckets. And so if there's not very many photons in there, that's a dark pixel. Each one of those is a pixel. So that's dark. It's a dark thing. So black is going to have not very many photons. But really, really bright light is going to have tons of photons. So what happens is, if you have a small photosite, a little small bucket, it can only capture so much. So it might have, in one photosite, not very many photons, but the next one, where the sun is, there's so many photons that it's just overflowing. What happens is that is called an overexposed image. It's clipping. It can't contain any of that information, and so it's totally blown out. There's no detail, because it's overloaded that thing. And so with small photosites, you don't really have the capacity to capture not very much in one photosite for the darks, and a ton in another one for the brights. And so you're very limited in your dynamic range. But if you could make that a big bucket, really big, deep bucket, in one of those buckets, you could capture not very many photons, and that would be for dark light, darkness. And then another one, you could capture a bunch of photons. And so you get the ability to capture darks and lights in greater ranges. And so the key is, you need a big sensor. You need a big, big sensor on your camera to build these buckets big enough to capture the differences in brights and darks. And to do that, you need a bigger camera, and those cameras are called medium format cameras, and they're going to cost you about $20,000. So that is why, that's one of the reasons why those cameras are so expensive, is because those sensors have about a 12-stop dynamic range. And if you think about it, remember, it's exponential. So 5 stops for our DSLR cameras compared to 12 stops for a medium format camera, that is a massive difference in dynamic range, massive. And so if you've ever rented one of those cameras or had a privilege of shooting with them, man, you're spoiled. You're like, oh my gosh. And also the shadow details and stuff that we're going to talk about in the last day when we talk about black points and white points, it really matters. So I'm not trying to sell you on a medium format camera, but I just want to say that the way your dynamic range grows or shrinks is either we modify it using flashes and filters and things like that in the camera, or we get a camera that can do more. So if you've ever seen like Peter Lick's work, has anybody been to the Lick Gallery? It's just amazing work. He hikes around with a huge medium format camera to be able to capture all this stuff. So a lot of people are like, how come my stuff doesn't look like that? I can't get it. You won't be able to get it without some equipment.